I am thrilled to reintroduce Ben Mills. Ben's presented to us before. We're thrilled to have him back again. He is an acknowledged expert in the domain of DMR. So Ben's going to walk us through the what's up with DMR, how to get into it, tips, techniques. We're very fortunate and very lucky. Ben, I'm going to turn the floor over to you. N4CV.
All right, thanks for having me back to Vienna Wireless Society. I was just looking back at my notes, and it looks like almost every 2 years I've come by and shared some updates on DMR. Seen some new faces along the way, and some familiar ones as well. So I wanted to spend a little time tonight reviewing and introducing some of the concepts about DMR, digital mobile radio, as part of an interesting corner of our hobby and digital voice in the VHF and UHF domain, and then make sure we spend a little bit of time talking about how to program a DMR radio, because that's something that always kind of happens near the end of the presentation, and we don't get a lot of chance to field questions and answer those sorts of things. All right, so the first topic is, what's this digital voice thing? And when I first did this presentation to this group in 2018 timeframe, that was a little bit more of a bigger question. What's this thing we're doing, and what are these noises that my FM radio makes when I land on a digital repeater channel? Just kind of in review, this is a nice block diagram out of QST that kind of goes over what happens when you talk into your microphone and it comes out as a DMR signal, and then obviously what happens in reverse. The first thing that happens, unlike traditional FM or AM modes, is our voice is immediately encoded by an analog digital converter or vocoder. Analog digital converter turns into ones and zeros, and then the vocoder provides a compression and forward error correction. So right out of the bat, we have a signal that's clean as it can be coming from our microphone, and then it heads forward into processing DSP in order to get ready to transmit it. In general, this stream is then passed to the modulator in the RF section, and so once you get to the 4FSK modulator and move out of the power amplifier, your UHF signal on DMR is just the very same as it is a UHF signal on any AM or FM mode. Same antennas, different kind of amplifiers, and we'll talk a little bit about that. But propagation is identical, and there's a couple other considerations being a digital mode that we'll talk about. So quickly, what is DMR as part of a digital, as a digital voice standard? As was mentioned previously, it's a public standard. It's actually produced by ETSI, which is the same group that defines Tetra, more popular P25 equivalent overseas. And the work that we do in ham radio is Tier 2, which is licensed conventional radio systems. That's on the commercial side, but DMR Tier 2 is what we're generally operating on with repeaters and digital voice. There's a Tier 1, which is very similar to overseas to what they use, and it actually is in 446, DMR 446 as I recall, and is their semi-equivalent of our FRS frequency band. There really isn't any vendor-specific hardware to DMR. There's lots of manufacturers that make equipment for it. However, they've all agreed to conform to the agreement set up by the DMR Association. So a couple of things that are different about DMR. The biggest is that it actually is a time-slotted mode. So our transmissions, as I mentioned, our voice is processed goes through digital signal processing, is actually broken up to take about half of the amount of time to transmit our voice packet than would be if I were to be speaking purely into an FM microphone and up converting. So we are we're time slotting for TDMA, which will be important here in a minute, it's designed for frequencies and propagation characteristics, in the VHF and UHF range, so generally 30 megahertz to 1 gigahertz. It's very popularly used as one of the common commercial standards for radio. So groups that used to use analog with PL tones, and we're thinking about commercial radio here for a minute. So in the not as much low band, but in high band VHF, UHF, 700, 800, 900 megahertz is where you'll find DMR radio traffic in the commercial world. So here's a little bit more about some of the differences between frequency division multiple access and time division multiple access. So if we think about our RF spectrum that our 12.5 kilohertz K4HTA repeater, 25 kilohertz K4HTA VHF repeater takes up, you know, one of the things that happened, I think it was 2014 at this point, was narrow banding. So FM in the commercial world went from a 25 kilohertz standard to a 12.5 kilohertz occupied bandwidth standard. So at that time, a lot of equipment was turned over, but this whole digital radio thing was starting to come around. One of the things that differentiates DMR from any of the other modes that are commonly used in ham radio is that it takes it occupies only 12.5 kilohertz, and that 12.5 kilohertz is further subdivided into time slots 1 and 2 that are 30 milliseconds wide. So as I mentioned, my voice would be captured by the microphone, encoded, and then signal processed to take up half the amount of time to transmit it. So my radio is actually only transmitting for 30 milliseconds at a time and then listening for 30 milliseconds at a time. So what we can do with this is I'm going to use Brendan as an example, and he's going to help me a little bit later with a bit of a live demo. But Brendan and I could both be utilizing a repeater at the very same time, occupying two different talk groups, and we wouldn't even be aware that the other one's on the repeater. We have one rack-mounted repeater, and we're both passing traffic through it. Our channel occupancy is still only 12.5 kilohertz. So, but I transmit for 30 milliseconds, and then Brendan transmits for 30 milliseconds. So, and that's the reason that we can get twice the throughput in the same channel. And I'll mention, as I mentioned, it went from 25 kilohertz down to 12.5 kilohertz bandwidth. So what these commercial vendors were seeing is their wideband FM channel. We could now pack two separate DMR systems, and each of those would carry two talk groups. So we'd actually quadrupled the amount of channels we could carry on our repeaters in the same bandwidth. Just something to consider from that. A couple other things. Manufacturers say that the battery life is a bit longer because you're only transmitting for half the time. Your PA is actually only keyed up. However, there's more DSP and vocoder power going into it. Encryption is possible because we're talking about a digital bit stream, although not at ham radio. We can operate in simplex and repeater mode. A very quick summary. I'll share my slides afterwards, and this is a breakdown of some of the differences between a few of the different digital modes, and this hasn't really changed in the 4 years that I've been working on this presentation and keeping it updated. And I'll mention two things I'd like to go back to about the time slots, because I think this is the right place to talk about it. We can only occupy the time slot that we are allocated. So our transmitters need to be able to key up and key down in that period of time, so we don't occupy the other time slot. Thus, my radio, even though there's no packets going across, my PA putting out a carrier and jamming Brendan's radio when he's trying to talk in the same area on the same repeater. So the way this works is the repeater is actually full duty cycle. It transmits in both time slots simultaneously at different modulation mode. And our portable radios transmit on, off keyed every 30 milliseconds. And so for that reason, again, we need to make sure that we are dekeyed when we're not transmitting, and we need to make sure that our radio conforms to the right timing standard. How do we do that? The repeater puts out a timing sync that the radios sync up to. If you're using simplex, the first person to transmit, their radio will actually send a period of ones and zeros at the beginning for everybody else in range to sync up with, and that'll become the timing source that everybody uses. There was a Bofang radio that came out a number of years ago that was DMR what's I guess DMR capable but non-compliant, in that they use their software-defined magic to create a DMR radio that transmitted every 30 milliseconds, but it keyed up the entire time. It was sold, people used it, and people quickly discovered that their radio PA was 100% duty cycle, thus jamming the other time slot when they weren't talking. The other thing about it is I mentioned amplifiers. Our conventional VHF or UHF brick amplifiers are generally designed for keying up and staying keyed up, and for FM, those won't work for the same reason. So I think there are a handful of manufacturers that make radios with transmit receive switch, generally pin diode switched, because you'd wear out mechanical relays pretty quickly with your DMR transmissions. And from a repeater side, however, it doesn't matter, because again, that's full duty cycle. So Crescend makes a popular amplifier, and Motorola has 100-watt repeaters and things like that. Okay, so as we talk about a little more about DMR and operating DMR, which is what we're going to talk about for the rest of the time. Share a little bit. There is definitely a rich background in the commercial radio world. So terms like code plug and personalities and things like that, you'll still hear those show up from time to time, which essentially means the file that you're loading into your radio in order to operate in a certain configuration. Most of the radios are most radios that operate DMR are easiest to program with a computer, where you can sit down and create your code plug, your file that you want to load into it, with things like the frequencies and the configurations for your frequency offsets, and some more of the digital features. However, a lot of them are getting a lot easier to program from front panel, and even better modify your configurations on the fly. So if you travel out of an area to make a change without having to pull out your computer, or if you make an error and want to type something into the front panel, you can do that. I've seen that done quite a lot more. The first thing we need to start operating on DMR is that every DMR frame, like most digital messaging protocols, you need to be able to identify your source and destination. So everybody needs a source. That's a numerical value that is associated with you. You can make it up, but the ham radio community has decided to adopt have an organization manage it, and so this radioid.net is the place to go, and they'll take you send them an image of your ham radio license, and they'll verify that it's authentic, and give you a 5 to 6 digit number to operate with. Again, this is something you have to plug into the radio. It can be 1, it can be 2, it can be anything you want it to be. But for some of the reasons we'll talk about later, it's a good idea to comply to what everybody else is doing, so people can communicate with you with your ID. Again, I also mentioned the two field in the message, and that will be either to an individual user in the case of a private call, or a group call, which will be to a talk group on a repeater. I mentioned talk group, so here's a good time to introduce it. Common terminology for a channel, sometimes called a squelch group. Others used to call it, we used to use PL tones to differentiate talk groups on a repeater. We are happy with one PL for everybody to use, but in the commercial world, in earlier years, you would have many different companies sharing a single repeater with different PL tones that operate as their squelch group. So you'd be sharing the random access repeater in that mode. So that's where this came along from. D-Star calls them reflectors, and Fusion calls them rooms. This allows users on the channel to be separated, and it propagates through the radio system and internet in that packet, as I mentioned. So your from ID and the group you're trying to talk to will always be attached together. So just kind of as an early introduction here, there's some common talk groups that exist. And we'll get to a little bit more to internet interconnection in a while, but 3151 is a common talk group ID to use to talk to Virginia statewide, and people hang out sort of in that room. TAC 312 is another one, and there's another one called Worldwide English, and you can kind of put your head together with internet connections how busy that channel is. And here's a channel that talk group is. So here's a channel. So a channel defines the RF parameters of transmit and receive. We have a color code, which is just like a PL tone. It has to be defined. This is how we could divide up, for example, if we had multiple systems on the same, operating in the same geographical area, they could differentiate themselves like we do with PL using color codes. Generally, there aren't very many systems on the same frequency that interfere with each other to need a color code. But if the K4HTA group had the frequency, and I'm sure in VHF and UHF we hear tropospheric ducting in the summertime, and we hear those North Carolina and New Jersey and Connecticut repeaters coming in. Using a different color code in different parts of the country could help with that. The talk group, as I mentioned, this includes the talk group to transmit to and from, and admit criteria. So you can actually program your radio to always transmit, just like we would with FM, and we get that doubling effect. But you can also program your radio, because it's digital, it's a nice quiet background noise. We don't hear static or any analog sounds. You may not know somebody's actually transmitting. You can program your radio so that you don't step on top of somebody by accident. So here's a quick example of a channel configuration in my MD380. We can see the important things to fill out here are what the channel name is, what I wanted to show on my screen. I need to identify the transmit and receive frequencies. The admit criteria I set as color code, which means if my system's free, let me talk. Then I need to define the contact name, which is the talk group ID to which I want to speak. So this 3151 was Virginia. We define this elsewhere in this programming file. Color code 1 and repeater time slot 1. The time slot's critical because you may be trying to transmit to a group of your friends on the same talk group ID, but you might be transmitting on the wrong 30 milliseconds and they won't hear you because they're listening on the other one. I just want to show you we can all talk to our friends on a repeater without the internet and without a defined radio ID and without even a coordinated talk group ID to talk to. Brendan and Mike and Kevin and I could get together and decide we want to use this talk group and we want to use the Vienna repeater, which is not currently connected to the internet, and our calls will go through. However, we wouldn't be able to necessarily interact with other people using those standards. So we've tried to adopt some standards that mostly for when we interconnect radio repeaters. Here's another example channel configuration from another radio I have, which is a Connect Systems radio. This breaks out, the channel name, the alias is only on our screen. We just need to get that color code, the time slot, frequencies obviously correct, and then we just have to pick who we want to talk to. There's really only 4 or 5 fields that we need. The rest of them are some kind of cool things we can do with this, probably for a later discussion. Once we have our group of channel configurations made that represent the talk groups that we want to talk on. Now we have our channels. We want to put them together in a zone. Another thing that comes out of commercial radio, and a zone could be organized geographically. Historically, they can only hold about 16 channels in a zone. And we'll make those available in our radio so that when we turn that channel knob, we're going through 1 through 16. But instead of like my iCom at home for FM, where I can just keep turning on a continuous rotary encoder, we're generally limited to 16. Again, it's historical, but from a commercial standpoint, remember all this stuff is built for Part 90 commercial, but we get a good deal on it on ham radio. Generally, 16 channels is enough for most businesses and what they're trying to do with radio. So we can select many zones in our radio. We just have to do a couple extra button presses to move between. A lot of people define it by repeater or maybe locale. Some people actually put the same talk group at all the different repeaters in the state, so they can always just move up and down their channel knob between cities kind of thing if they want to stay on the same talk group. It's totally up to the radio owner. Repeaters operate very similar to your analog repeaters. Except they provide 2 independent talk paths, 1 per time slot. They don't require internet access. Typically VHF and UHF and ham radio, 70 centimeters and 2 meters are the popular areas, although there's some 900 megahertz around here. The 900 megahertz gear can actually be bought a bit more cheaply on eBay, and it's much shorter coverage. But when we're in the cities like around here in our urban areas, it actually does pretty well and can serve quite a few users. I think Motorola and Bridgecom are still two of the most popular repeater manufacturers for DMR. Bridgecom has like a full page ad in every QST I see. And they've got some videos and how-tos on all of these things. They'll sell the repeater. They'll make deals with clubs. I know some clubs who have gotten together and said, hey, we want to buy a repeater and 20 handhelds, and everybody pulls in on it. And Bridgecom is cool that way. Motorola is not. So looking at what a repeater site looks like, this is, I believe this is the original Herndon repeater in this area. We have what we're used to seeing from the top to the bottom, the duplexer, power amplifier, power supply for the power amplifier. The repeater is only that little 1U device. It's a 50-watt UHF repeater. And then firewall and switch for the networking part of it. Okay, so repeaters can be networked together to share talk group. We have done some pretty, the hams have done some pretty ingenious things with linking repeaters together to make gigantic networks, and then even better yet, bridge the networks together so that the local Northern Virginia network has cross connects out to different places, different other networks. Some of them are much bigger. Global or nationwide networks, and some of them are more regional, and you might want to cross connect around here. For example, there's some folks who came from the Chicago area, and so they want to carry one of the Chicago rag chewing channels, and so they've set that up as a personal preference, and they bought the repeater so they can, but there are a lot of talk groups available on a lot of the repeaters around here. So the two common ways that we'll see this is via C-bridge, which means the repeater owner sets the repeater owner and working with the system owner, system being 1 to 30 or so repeater sites on a C-bridge. They'll define what's available and on what time slot mic. However, when we look at something like Brandmeister, we, the user, can identify pretty much any talk group that we want to access. The repeater owner has some control. They can lock it down during certain hours or things like for nets or for various things. But for the most part, of the over 500, probably 1,000 talk groups of at this point that exist, any user with their radio can key up and pair that time slot on that repeater to the Brandmeister talk group for that period of time. And then when there's no activity for a certain period of time, or after a 15-minute or whatever timer passes, that connection's torn down and the repeater is available for anything else, or to reactivate that channel, that connection. So thinking about the two configurations, we've got the C-bridges and then we've got Brandmeister. There's some other networks, again, they're generally using C-bridges if they're not Brandmeister. So we might have heard some of these terms like DMR Mark, K4USD, PRN, DMR Virginia, which we'll talk about in a minute, and Interstate, which has taken over some of the local repeaters. So those are groups of repeaters that have made these very large systems. The other way, which I don't have a lot of context around, are hotspots, and these are extremely popular in ham radio. So we're very fortunate in this area that we have a lot of DMR repeaters, and we don't really need to have infill in our homes with our own RF device. However, a lot of people prefer and like to operate in this way, and especially if you're out of range of a local repeater, it really makes the hobby a lot more fun and accessible. The other thing is you can control everything yourself, and so if you prefer during certain times that nets are automatically connected or things like that, you can make it happen. So these are generally low power. They're kind of cool because they're built often off of like single chip radios. They're usually a few tens or hundreds of milliwatts, so they cover your house or your living room. You can program them completely from your computer. They're inexpensive. And there's some other cool things that they do with them. The one on the right, the OpenSpot 3, actually is really neat. It has the capability to bridge modes. So if you had a remember, these act like a small simplex repeater in your home. So if you had already purchased a Kenwood or an ICOM D-Star radio, you can program the OpenSpot to talk to your radio on a D-Star channel, but then take the audio, transcode it, and send it out onto the DMR network to join like that Virginia talk group or that Chicagoland talk group or that Florida game fishing morning chat, whatever talk group you want to get onto. And I say that somewhat amusingly, but there's thousands of talk groups available. A lot of them are neat technology folks that are diving into, having nets about DMR and about other topics. There's the folks that have, affinity groups and hobbies in common that they want to have a net or activities for, hang out with their brethren on ham radio, and they may be scattered around the country or globe, but can stay in touch using digital radio or digital modes. So again, that open spot is the one to look at. It's the most expensive, but it does offer some kind of interesting cross mode capabilities. So there's other things. It's a digital, our voice is packetized. It's a digital stream. You can send a lot of other stuff through it too. You can do text messaging, so you can send a message from radio to radio. Private calls, which means that Mike and I could establish a private call over the repeater, which instead of making a call to one of those talk groups that everybody's listening on, I make a call directly to his radio ID, and then we're basically in a one-to-one conference. It's not secure. It's not private because people can still listen to it, but everybody in town's radios don't unsquelch while we make a quick, coordination for meeting for pizza. GPS tracking, you can do, there's a DMR version of APRS that folks are doing. Roaming is interesting because, again, since now we have these talk groups that are carried over wide area systems, or perhaps 8 or 10 repeaters throughout the state of Virginia, now we might want to roam. So we might want to be able to drive down I-95 and have our radio based on signal strength drop from one repeater and grab the next repeater from DC to Fredericksburg to Richmond to Petersburg and to Southside. So that's pretty cool. And then talk around in simplex, as I mentioned, we can do that. Like if we're going to Dayton, we can talk on simplex and DMR, and when we get there, choose a frequency and operate on. So here's some very old that I didn't get a chance to update, but numbers. It's because it continues to grow. We had 2 years ago 2,100 DMR users registered in Virginia. Repeaters, there are 133 registered in Virginia. These aren't the hotspots. Okay, quickly about some DMR radio options. There's lots. There's even more than I have on my list now. They're really up to you. Mobiles and portables the same way. More power, better receivers, those sorts of decisions. Many are analog capable, but at this point, what are we really talking about? Like the Anytones and the Connect Systems of the worlds, they're dual band, VHF, UHF. They can do analog and DMR. I think that Anytone even has 220, and I challenge anybody to be the first to put the 220 DMR repeater up to be the first. You have to do it yourself. There aren't any off the shelf. So, here's a couple pictures that are pretty. The MD380 was extremely popular. You can get them for a song and a dance now because the 390 came out, and now there's the dual band 380D and things. I liked the MD88 or whatever that was in the middle. Tytera is the manufacturer of these. Tytera with a T. Connect Systems, they don't make the radios, but they make firmware and features for them. So they have the dual band, these $300, $240 entry points for digital radios. The Tytera, you buy other ones I mentioned, you can buy on Amazon for $90. Anytone, these are really nice. I know a lot of people who really enjoy them. The 878 is really popular. Yep. I think a lot of guys here bought those 868s and 878s. I think there was a group buy a few years ago for those. And they even have a mobile, and their mobile has like a remote PTT you can put on your steering wheel and put it on Bluetooth. They've really, because there's such a large market for these radios in the commercial community, they're really kind of pioneering, you could say, these somewhat obvious features for radios to make them more modern, like Bluetooth, pairing with your phone, as Mike said. Some of them, I think, Connect Systems sent out an email that they were trying to figure out how to let you, program it with your phone and pair it. So as you walk, I think the new Motorola radio does that too. So you could actually use the data message to send text message and things from your phone. Motorola, they make good hardware. They're a lot more expensive. You can find them on Amazon. The 6550 radio the top left radio was canceled in 2015, but they're still around. It's still a very good radio. They use the same accessories as their later counterparts, and so you can still get programming cables and things, and speaker mics and whatnot for all of these. They even make a little cell phone, candy bar phone looking one in the bottom left corner. They've got a couple mobile options. Here's a cool one. There's a couple brands that make this one now. This is an Android phone with I think a 4-watt radio paired in the back. I know someone who just got the tablet version of this that has like 2 radios built into it. So, people are like, well, if I can, I will, and somebody will buy it. But pretty interesting. Like this, for example, here's a picture. They're showing like the ARL repeater book. Scroll through it on the Android phone and click on it, and the radio pops over to that channel, and you're in that mode. Pretty neat. Okay, so we can talk a little bit about local systems. We'll kind of go through these just for awareness. DMR Virginia, there's a link here, and if we have time, I'll pop up in their website. They have great coverage through a lot of Virginia. They filled in, since I did this, they filled in a couple of areas in the east, and they've also started to partner with a group out of Southwest Virginia, and I think into like North Carolina, and they're converting a lot of analog repeaters into DMR and joining them onto the network. So that's pretty cool. And this is where I mentioned roaming. Like you can go down 81, 95, 64, and stay on the same talk groups as you go, and your radio cuts. So, we'll drop a signal when the repeater RSSI hits a certain level, and then it'll roam and look for the next site and pick that one up and keep that going. So you can more or less seamlessly operate as you drive around. In DC, we still have the W3AGB in Alexandria. Linden is a great repeater out west along the ridge near very high. I have great coverage from it. I live out in Loudoun County. It covers a lot down into Fairfax. You can see the shadow of Bull Run Mountain here by the plains, but there's a repeater there's at least one repeater up on Bull Run Mountain that can fill in there for you. Going down 95 toward Fredericksburg, there's a repeater. Alexandria Club has a repeater. And then the latest news as of this year is the folks that I work on DMR with in Virginia, in Northern Virginia here, we've converted from our own C bridge we've converted our C bridge over and joined it into the Interstate network, DMR network, which I'll show you the link to in a couple of minutes. And so the repeaters carry a lot more talk groups available on them, and they have some more linking capabilities. One of the other things we're working on doing, we've changed over the talk group formerly known as Nova Local. We've turned into DC Regional because of Interstate, we are sort of the DC, Maryland, Virginia, Delaware area local channel. The details remain the same at Herndon. One of the other things that's funny about DMR and digital radio, and because of what our screens show, like when you can program it to say anything, I don't memorize frequencies anymore. So often I have to go back and look up, okay, it's 442-4375, because you're not hand jamming it into a radio and your display doesn't show the frequency. So you're just not used, you're not used to it. It's like, this is the Herndon repeater. There's a Herndon. In Herndon, there's also a 900 megahertz repeater. Arlington has a pretty good repeater in Boston area, right by the Boston Metro, that does a lot better in the downtown area. And then there's some at Vienna, some in Vienna. This is kind of on the north side of Vienna, close to Reston, at the control ops house. So there's a UHF, VHF, and a 900 there. So from where you all are operating, you might have good luck, especially on those parades and things. You're operating downtown. Might be a nice local repeater to use, so you're not contending with wider area traffic. A VHF also in Herndon. And then in Herndon, I have a repeater up on Brandmeister that is not on the C bridge. This one kind of favors a little bit away from Vienna, favors the northwest a little bit based on where it's located. But this one is the type I was telling you about, where you can activate, you can read about how to use Brandmeister and program in, like if you wanted to join the Florida fishing net at 5 a.m. as they're leaving on their boats, and you can and you want to join the DMR net, you can bring up that talk group and operate on it, and then tear down the patch when you're done. Generally they're set up on the repeaters to tear down the patch automatically after about 15 minutes with no local transmits happening, just to keep from having them tied up all day. So Brandmeister is available locally. You can look in Repeater Book. The ARL Repeater Directory, I think, shows DMR now. Repeater Book, I really like the app that they have for my Android, and also their website's pretty good. And I mentioned we can use simplex. I'll share this. You don't really need to write this stuff down right now, but there's some common simplex calling frequencies for DMR. So let's talk about how to get on the air. Apply for a radio ID, because now we know we're connected to the internet. We have other people listening to us. We want to talk to other people. I want to have an ID that identifies myself. My radio's packet in the messaging in the to frame or from frame will always show 3151768, which is me. And then everybody else can program their radios, and with the lookup table that wants to know when I'm talking, 3151768 will just show up. Ben is Ben on the screen, N4CV. The radios have enough. Most of the radios have enough memory that you can download all like 10,000 US radio user DMR users, and so anybody who ever talks on any of the nationwide channels, you get to see on your screen and know who you're talking to and look them up in QRZ. So this again is the link. We'll go there in a minute and take a look. Further reading on DMR still stands. Like I mentioned, I don't think I have in here, but the company Bridgecom, who you can't miss their multiple full page spreads and on the back cover of QST. They have a lot of videos and how-to guides, and they'll even offer to program your radio for you before they ship it. So Bridgecom's, I think, a pretty good resource. I haven't really reviewed them myself, but I've heard people who have kind of learned a lot more about DMR that way. Okay, get involved, join the nets, use DMR for emergency communications, throwing up a repeater on a hilltop, a supportable repeater. You now can carry 2 conversations, and the effort you carry, channels per pound pays off. The interoperability, local hotspots, microwave linking. Think about things like the Arden project and the ham, the ham IP-based projects that are going on. There's some telemetry features. You can actually use them for widgets around your home or your farm. You can use DMR on the back connectors of the radios. There's a 20-pin connector, and you can program your radio to, if one of them shorts together, it sends you a text message on the ham frequency, or if your cistern's overflowing, you can have it light up a light in the other side of the room, all built into the radio, which is kind of cool. All right, there's my contact information, and I did want to make sure we spent a little bit of time tonight talking through a couple of these things. So here's the DMRVA website. As I mentioned, Virginia DMR. We can go look at their. This would be a good place to start. They'll publish news when they bring up repeaters online and things like that. If we go to the repeater list, we can see where all of the repeaters are and those maps that I showed you. And then if we go to the Talkgroups list, we can see who we could talk to. So they have a nice little breakout of how they've configured time slot 1. And then scrolling down to time slot 2, which is, I guess they put Virginia statewide on time slot 2, and it's kind of one of the only things. It's a very busy. It's often a very busy channel because it's a statewide channel. And then you can see some of the things that they have, like they've linked with the Outer Banks network and some of the repeaters. Tidewater repeaters are kind of linked together. They have a Tidewater regional, Peninsula regional along the Delmarva. And then we have, we're not carrying it on DMR Virginia yet, but as I mentioned, the DC regional would be this area. Okay, so then each state has a statewide channel, generally carried on those states' websites. And that's a little bit more about DMR Virginia. Let me just quickly share. This is when you understand how to read a matrix like this, it really helps. So this represents the 1C bridge, the DMR Virginia C bridge. We look down the left side and we see the call sign and the frequency and the city where that repeater is located. And then this is a different display of that information I just showed you. This shows you all of the talk groups that are available on which time slot. And you can see the talk group ID number that you need to program into your radio. And then it'll show the availability of it. For example, the Tidewater channels generally aren't carried in Western Virginia. So Interstate DMR has a very similar thing, but it's a lot harder to read because there's a lot more channels, talk groups arranged in it. But here we can see, this is one of 3 interstate bridges. So they actually have run 3 C bridges because they have so many repeaters in kind of the greater DC, Maryland, Virginia area, Delaware, and elsewhere. So they have actually 3, and this is one of the 3. Generally, when you're using a C bridge, you're going to be able to access this website backend to the radio repeater system. And that's going to allow if someone were to transmit on their radio, you'll be able to monitor for that call, and it might be you because you're trying to check your signal level or ensure you're actually getting into the radio system. So looks like KM4HR is currently transmitting on one of the channels, and at the top he will show up in the current calls list, and then he'll immediately fall into, once he's finished transmitting, he'll fall into the recent history, and he's going to continue to fall down through the recent history. But very quickly we can catch KM4HR Brendan. We see that he was on DC Regional. He had a -104 RSSI, which is marginal, but enough to carry a conversation. And it also shows he's on repeater 315121 in Herndon, Virginia. So you can use this for yourself to see if you've configured your things right, if you're really getting into the system. And also, if let me get him to do it again, you can also view this control center peer watch. And if he transmits again, these are all the repeaters he's keying up. So as I mentioned, the difference between using local channels and wide area channels, since he's keying up a wide area channel, we just saw he keyed up about 12 repeaters because he's on a regional channel. So keep that in mind. We're using the fewest resources, kind of like we use lowest power necessary to maintain communications. We want to use the fewest resources. For us to talk around town, we should use the local channel and not tie up, maybe not use worldwide English channel. I think that I'll stop there and see how we're doing on time. And I'd definitely like to field any questions if time allows. Back to you, Don.
Ben, thank you so much. You are clearly a wonderful resource for the club. DMR is an exciting aspect of the hobby, and thank you so much for your contribution.